Good afternoon, grade 8s. For natural sciences, this afternoon we are going to discuss a very interesting topic, the radiation of light and the spectrum of white light. So what you need to know about the radiation of light is firstly that light is emitted or sent out from luminous objects. So you can see that there are two new words in this sentence. Emitted, or to emit means to send out, and luminous means that an object sends out its own light. So light is emitted from luminous objects. And what are the luminous objects? They emit or give out their own light. So those are the two new important things that you need to remember. So what are examples of luminous objects? It can be objects like the sun, because the sun is always shining and it emits its own light. A light bulb that is switched on, a candle that is burning, a switched on torch, or something like a firefly that we can see at night sending out or giving off some light. And then very important, the other thing that you need to know is that light is transferred through radiation. You can see on the picture on the right-hand side, the way that the light and the heat energy from the sun reaches the earth is through radiation. So light is transferred through radiation. And another very important point here is that light only travels in straight lines. Light can never go around a bend or can go around a corner. Light can only travel in straight lines. And then something very astonishing is that the speed of light is 300,000 kilometers per second. So light moves extremely fast, 300,000 kilometers in 1 second. And that means that light can move 7.5 times around the earth in 1 second, which is really astonishing. So let's look at examples of luminous and non-luminous objects. You can see here on the picture on the left-hand side, we get luminous objects, objects that give off their own light, like the sun, a firefly, and a torch. But now you get natural luminous objects like the sun and the firefly. And then we can also get artificial luminous objects like a torch that works with a bulb or a candle that is burning. And then on the right-hand side, you can see non-luminous objects, objects that do not give off their own light, like a pen or books or a table or clothes, etc. Then how can we prove that light only travels in straight lines? So you can see there on the picture, the photograph where the sun is shining through the clouds. You can clearly see there that the way that the rays of light are being transmitted is that they are only moving in straight lines. You can see they don't bend or anything. It's light moves in a straight line. Another way that we can prove that light only travels in straight lines is if you have three cardboard stands with a little hole in each of the stands, and you put a candle on the one side and you are sitting on the other side and you want to see that candle. What must be true for these three holes? They must be in a perfect straight line. So you can see the light traveling from the candle to your eye. It's always from the object to the eye. Those holes must be in a perfect straight line. If you move only one of these holes, maybe slightly to the left or slightly to the right, then you won't be able to see the light from the candle. So as long as those holes are in a perfect straight line, then you will only be able to see the light from the candle, proving to us that the light traveling from the candle to your eye moves in a perfect straight line. And here at the bottom, you can also see another way that you can prove that light only moves in a straight line is if you have a plastic tube and you look through the tube at something like a candle or a light bulb, while the tube is straight, you will be able to see the light coming from that object. But the moment you bend the tube, then you won't be able to see the light coming from the candle or the torch anymore. That proves to us that light definitely cannot move around a corner or a bend, and it can only move in a straight line. Then there's a third way that we can prove that light travels in straight lines, and that is through a pinhole camera. Now, I hope that in your class, your teacher maybe demonstrated the pinhole camera. You can also make one yourself using a shoebox or any kind of a box, even a box in which you buy some biscuits or cookies. So if you build your pinhole camera and you look at an object, you will see that the image on the side of the box on the screen will be upside down. If you look at this picture, the lamp is upright when you look at it, but through the pinhole camera, the image that you see there that you are looking at will be upside down. And the reason for that is demonstrated in this ray diagram on the right-hand side, where you can see the object, the candle, and light moving from the top of the flame through the hole on the side of the box to the screen can only move in a straight line. And then the other ray of light from the bottom of the candle through the hole to the screen will cause the candle to be turned upside down. So the light coming from the top of the candle will now be at the bottom, and the light coming from the bottom of the candle through the hole will now be at the top, causing the image to be turned upside down. And that's also a proof that light can only move in a straight line. Then the second thing that you must know in the lesson of this afternoon is that we can get the spectrum of visible light. Now, what do we have in this photograph here? We have a ray of white light being shone on the side of a triangular prism, and then inside the prism the light is dispersed. That is also a new word. Dispersed means to be split up into 7 colors. So on the other side of this triangular glass prism, you will see 7 colors of white light, and they are red, orange, yellow, green, blue, indigo, and violet. Violet is just a very dark purple, and indigo is a kind of a bluish purple. So those are the 7 colors of light that we can actually see with the naked eye. But for interest's sake, there are also other types of light that we can't see. For example, infrared light. It's next to red on the spectrum, but we can't see it. Infrared, we can feel it. It's heat waves. We can feel heat, but we can't see those light waves. And then on the other side of violet, we get rays of light called ultraviolet lights. Now, ultras also, those frequencies are so high we can't see them, and that is the kind of radiation that we experience from the sun. So you must know that white light can, through a triangular prism, can be dispersed to form the spectrum of white light, which are the 7 colors of the rainbow. Now, what else do you know? Do you need to know? You must also be able to draw a ray diagram showing how the spectrum is formed. So in this diagram, you have a triangle for the glass prism, and then there's a ray of light, a line with an arrow indicating the white light, and then you can see inside the prism, the light is being dispersed, and where it exits the prism on the other side, the right-hand side, you can see the 7 colors: red, orange, yellow, green, blue, indigo, and violet, the 7 colors of the spectrum or the rainbow. So what do you need to know about the spectrum of visible light? Firstly, you know now that white light consists of a spectrum of different colors. A spectrum is a range of different colors from red to violet. And you must know the order in which these colors of light appear in the spectrum. It's first red, then orange, then yellow, then green, blue, indigo, and violet. Excuse me. So you have to know the order in which these colors of light appear in the spectrum of white light. And the easy way to remember that is if you remember the letters in the correct order: Roig Biff. So R is for red, O is for orange, Y is for yellow, G is for green, and BIV is for blue, indigo, and violet. So remember Roig Biff, and then it will be easy for you to remember in the order in which the colors appear. Then another thing that you should know is that every color has a very specific frequency and a very specific wavelength. Now, we're not going to go into too much detail into that, but you can remember that the red part of the spectrum, red, orange, and yellow, the red part, especially red, has the lowest frequency and the longest wavelength. Now, you can see on the right, the picture here with a red line. Red is a wave, a wave of light. So the crests of those, the peaks of those red waves are very far apart, and that's why we say it has a very long wavelength. But on the other hand, blue, if you look at violet light, it will have the highest frequency but the shortest wavelength. So those crests are very close to each other, and that is what we mean by a long wavelength and a shorter wavelength. So you must please remember that red has a long wavelength and a very low frequency, but violet has the highest frequency but the shortest wavelengths. So make sure that you remember that. Now, where in nature can we see the spectrum of white light happening naturally? In a rainbow. So the sentence there you can read with me: a rainbow is seen when light falls on water droplets in the air, and the white light is dispersed or split up into the 7 colors of light. If you look at the picture or the diagram on the left, you can see white light coming in. It hits a water droplet, and then the water droplet acts as a little prism, and inside this droplet, the light is dispersed or split up into the 7 colors. And now you must remember, there are millions of these water droplets in the air after a shower of rain, and then you will get this huge rainbow forming in the sky, as you can see in the picture on the right-hand side, the photograph there. Now, I hope I hope this was a good recap on the spectrum of white light, as well as the radiation of light. And now you can complete the quiz and see if you can get those answers right. There are 12 questions, and all the best of luck with those. I hope you get it right. Thank you.